Assalamualaikum warahmatullahi wabarakatuh. My name is Fikri, and I'm from Computer Organization and Architecture class, section 09. And in this video, I will explain some of my work during working on this library project. I will explain 5 numbers of problems. 2 of them will come from the activity 1, and the 3 others will come from activity 2. So, okay, let's start it. Let's get started. So for the question 2 on activity 1, in activity 1, here we need to find out each flex value for that we're being asked. So how we're gonna solve it? First, we need to run the program, and we need to go to the register box. Here we can see the OV and UP, EI, PL, ZR, AC, PE, and CY. But we're gonna use the OV for overflow flag, PL for the sign flag, ZR for the zero flag, and CY for the carry flag. Okay, so here we can see the value for the changing flag. So we're gonna move the arrow down first. So as we can see, there is a bit change in the value of the flag. OV becomes 1, and then here we just ask about on the overflow and the sign flag. So we're gonna see the PL and the OV. Here the value of the OV is 1 and the PL is 1. Then we move on. For the line 2, we FNGF means we are gonna see the PL and the ZR. Both the result is 0. And for the line 3, we need to find the CF, which is CY, CF, PL, and OF, which is OV. CY, the result is 1, SF, PL, the result is 0, and the OV, the result is 1. And then the last line, ZR becomes 1, and CY becomes 0, and SF, the PL becomes 0, and the OV becomes 0. So that's for the question number 2. So we're gonna go to the question number 3, activity 1. So we are given this data. So we are given this data. We were given this data, and we need to find. We need to call the byte. We need to move the run to the register, the memory to the register. Sorry. So first, I'm gonna erase this part and then copy paste it. So the first question we asked to move my bytes, first 2 bytes of my bytes into the DX register, and the second to move the 4th byte in my words into the EL register, and the last is to move all 4 bytes in my bytes into the DX register. So how are we gonna do this? First, how to call the first 2 bytes of the my bytes. So as we can see, the my bytes data type is byte, but we want to move it to the DX register, which is actually 16-bit memory register. So we need to use the PTR function, which is to overcome, the function is to override the declared size of an operand. So how are we gonna use the PTR? It's actually the same as the normal move. We just need some addition. We use move and then the destination, and then we put the destination types of size of memory, and then we write down the PTR and then our data name. So here we use the move dx, word PTR and then types my bytes. For the second, we need to call out the fourth byte of the my words. So here is it is an array of data. So the normal, if we just type the my words, not using the +3, it will just come with the, wait, it will just come with the first byte of data. So let me give you an example. So here we press F10. So it is a normal, we see the EX register. So here if we use, so if we use the my words +3, the value will call for the fourth type, the fourth order of our data. So 43, which is this one. But if we just use the my words, we just call the number 0, the order of number 0 of the data, which is 23. We use the little endian order for this assembly language. So, and then for the last move ex, comma the word ptr my bytes, we need to call out all of the bytes to the ex register. Oh, and for the second question, it is quite different from the first question. If from the first question we need to put from the small size to the large size. For the question 2, we need to put the large size to the smaller size. So for the third question, I will erase the second question to is my explanation. So how are we gonna put all of the byte into the EX? So it's actually just put all of this with the PTR and then types your data name. So you can see here. So for the first the EX is normal, the normal size of it, and then we use the move function. So we can see here, your PTR my bytes, the value become 40, 30, 20, and 10, which is actually came from this one, 10, 20, 30, 40. Don't forget we fill the the address or the offset with the little endian order. So, and then we are gonna continue to the another activity, which is activity 2. I will start from the question 3. Here in the question 3, you can see the question is to write a program to sum all of the elements of array Fiona, which is array of Fiona is from this question. Question 1. So I will just type the data of Fiona. So what we need to do, since this is an array, so we just need to use Fiona and then Fiona 2, which is, since this is word, which is the size of it is 4 for each word. So if we want to call the second array, we need to plus 2 it, because from the first 90 is actually 0090. So, oh, sorry, 90 in, this is 90 in decimal. So 90 here in hexa is 5A. So, and then we plus it with the 95 in hexadecimal. It become EF, and then plus 4, plus 6, plus 8. And then we got the result of the EX, which is in hexa. It become this value. So moving on, question number 5. Here is more on loop function. So here we are given the value of 24 to the AX register. So we are gonna use the loop. We need to, if we are gonna use the loop, we need to use the register of ECX as the counter of the loop. So we need, first we move the, we want, in this function, we want to increase the value of EX and then negate it and then increase it again and then negate it until here 12 times. So we wrote move ECX, 12 to tell that we want to looping the function until 12 times. So we're gonna run this. We're going to run this one. So here we can see move. You can see from the EX value, it increased from 18 to 19. And then continue, keep increasing until 12 times. So the value, the final value for the EX, since this one is an EX, so we're just gonna put 4 numbers of it. So the value is 0018. So for the last part, same loop function. So here we want to set the EX value register to 0, and then we want the loop count of the loop to be caught 7 times, which is actually, this counter is actually a data value of double word equals to 7. So we're just gonna run this. So first we set the EX to 0, the EX becomes 000, and then we set the counter and then add the EX with the 10. As you can see, the EX becomes 10 here. If we're gonna look, plus 10 plus 10 plus 10 until the final is 70, and then we move back the EX to our total. So the total become in the autos. So the total become same as the EX, which is 70 in hexadecimal. So that's all for my discussion on my lab project. For me, this lab, third lab, this is my third lab during this yoga class. And what can I reflect? I think the work for this lab is actually a bit more easier compared than the previous lab, maybe just because maybe because I just more known about this assembly language. I mean the basic one. So not just the previous one, which is I actually a bit strange with it. And then my what is a part of project that I was actually having trouble of it is actually the part of making this video. I don't know. I just a little bit. Actually, a person that introvert and less talking. So for me to talk like this, talking much in webcam, it's kind of quite hard for me. So, but I think it's great for sharpening my soft skills. But so far so good. Yeah, but I think that's all. Thank you for watching this video. That's all from me. Assalamualaikum warahmatullahi wabarakatuh.